Okay, last thing we can do here is have you do these same types of problems, but for something other than water. So I made a substance up called XYZ. And this problem, we're going to be using this made up substance, but doing the same type of thing. Maybe it's one step, maybe it's 5 steps, maybe it's somewhere in between. So the tricky thing here is remembering that your melting point and your boiling point are not 0 and 100. And then also sometimes people get messed up with negative numbers here, thinking one's bigger or smaller than the other. You'll see. So in this case, we're going from 50 to negative 20. Is negative 15 somewhere in that path? Yes, negative 15, my melting point, I'm going to label it, would come above negative 20. Is 40 somewhere in that path? Also, yes. So here you'll see a full 5-step problem when we're going from 50 to negative 20. I labeled boiling point and melting point so that I remember when to use what value. Above the boiling point, we have a gas. In between the boiling and melting, we have a liquid. Below the melting, we have a solid. And that should be it. So my graph, we cool the gas down to the boiling point. Then we, opposite of boil it, condense it. Now it's a liquid that we can cool to the melting point, which we can then freeze. And then we can cool that solid even further. So this would be 5 steps. Step 1, we are cooling a gas. I reminded myself that it was a gas. 12 grams of it. The CP of a gas for this substance is 2.5. The change in temp from 50 to 40, 50 minus 40 is 10. It would help if I typed it correctly. 300 joules. My second step, since it's at the boiling point, it's a flat line, therefore it's a phase change. Since we're at the boiling point, we would use HV rather than HF. (21,360 joules. My third step, we are cooling what is now a liquid because I just condensed it in step 2. Still have 12 grams of it. Liquid for this substance has a CP of 3.15. Delta T from 40 down to negative 15. If you're not the best with numbers, literally type it in your calculator. Bigger minus smaller. 40 minus negative 15. It's actually a change of 55. That's what I mean by people messing up negatives in these problems. 2,079 joules. Our fourth step is at the melting point. Therefore, we're either melting or freezing, but a phase change. In this case, we'd be freezing. HF is what we use anytime we're at the melting point. (3,300 joules. And finally, step 5, we are cooling that solid even more. Since it's a solid, we use 1.85 for whatever this XYZ thing is. And it's changing temp from negative 15 to negative 20. Do negative 15 minus negative 20, bigger minus smaller. Or you could know that's a change of 5. We get 111. To get my final answer, I do 300 plus that, plus that, plus that, plus that, add it all up. Which, if I typed it correctly in my calculator, is 27,150 joules. Since we started at a high temperature and went to a low temperature, we must have released heat. Go try.